let's go over loops. The less code that you have to write, or the more efficient you make your code, the better. It's good to have a smaller program, making it easier to create, fix, and modify. One way to do this is to reuse existing code. In the past, we've seen functions that can be called again and again to reuse code. Now we'll see how we can repeat one or more instructions over and over again using a loop. Perhaps you want to calculate a series of numbers and display them on the screen. If there were 3 numbers, it wouldn't be that big of a deal to calculate each one and to display them like this pseudocode. Calculate weekly total for week 1 and display that weekly total. Calculate weekly total for week 2 and display that weekly total. Calculate weekly total for week 3 and display that weekly total. But what if you needed this weekly total for every week during the year? That would mean you'd have to repeat this code 52 times. If we know how many times we need to repeat the code, we can use a for loop like this pseudocode. For week equals sign 1 to 52, calculate the weekly totals for the week and display those weekly totals next. The 2 lines of code in the middle would repeat 52 times for each of the weeks with only these 4 lines of code. The syntax will differ for the for loop depending on the programming language. Loops will definitely help shorten the amount of code, but they can also be hard to read and understand. Comments are good to use with loops to explain what the loop is doing. Loops will definitely help shorten the amount of code. A for next loop typically consists of 3 items. A variable to use to count how many times the loop is repeated, an initial start value such as 1, and an ending value. Say we wanted to get the square root of the numbers 1 through 10. Here's what that would look like in a few different languages. With BASIC, it would say for I equal sign 1 to 10, print, then in the string the square of, and then it would say I is I times I representing 1 and then through 10. And then it would go to the next I, and it would do that 10 times and then end. C++. For, and then inside parens, we have 3 different things. We have the integer I being set to 1, the condition I is less than or equal to 10, and the incrementing of I by 1 each time. Inside the curly braces, we're outputting the square of I is I times I. In JavaScript, for, and then inside the parens, the same 3 types of setups for the for. We have a var I is being assigned 1, the condition I is less than or equal to 10, and an incrementing of I. Document.write, or outputting the string of I is I times I. And then in Swift, for I in 1 ... 10, inside curly braces, printing out the square of I is I times I. For both the C, For both of the C++ and the JavaScript, following the keyword for in the parentheses, you have 3 parts. The initialization of the counter. This only runs once at the start of the loop. Then we have the condition or decision to be made on when the loop runs. And 3, incrementing or making sure the counter has 1 added to it each time the loop runs. If you forget to increment each time, your loop could run forever and never end, becoming an infinite loop which will crash your program. So the variable I is used for the initial number. It is assigned a 1 in this case. The condition then returns a Boolean value of true or false, and that is the I is less than or equal to 10. So when I becomes 11, that condition will be false, and the code inside the curly braces will not run anymore. It will jump outside of the loop and go to the code below the loop. If you need to go up by more than 1 for each loop, you could use something like I is assigned I plus 2, for example, to step up by 2 each time. So without the loop, in order to get the same results, you'd have to write, for example, in C++, outputting square of 1 is 1 times 1. Outputting the square of 2 is 2 times 2. Outputting the square of 3 is 3 times 3, all the way down to the square of 10 is 10 times 10. If you had to do this up to 1,000 times instead of 10, think of how much code you'd have to write. Let's go through each of the loops with the C++ code. So we have for, and then inside parens we have the an integer being set to 1, semicolon, I less than or equal to 10 is the condition, semicolon, I plus plus is the incrementing. Inside the curly braces we have the output of the square of I is I times I. So the first time it will be I will be 1 because that's how we initialized it. The condition is checked, is I or 1 less than or equal to 10. That is true, so we can run the code inside the curly braces. So the output for the first loop would be the square of 1 is 1. The I plus plus makes sure that the I is incremented up to 2 the next time we go through the loop. The condition is checked again. Is 2 less than or equal to 10? That is true, so again we run the code inside the curly braces. So the output for the second loop would be the square of 2 is 4, or the I times I, the 2 times 2 is 4. So it would say the square of 2 is 4. You repeat this code to 3, 4, 5, 6, 7, 8, 9. After the loop 9, the I plus plus makes the I increment to 10. The condition is checked. Is 10 less than or equal to 10? This is true, it is equal to, so we can run the code inside the curly braces. So the output for the 10th loop is the square of 10 is 100. After loop 10, the I plus plus makes the I increment to 11. The condition is checked. Is 11 less than or equal to 10? This is false. So the code inside the curly braces will not run this time. The program will start reading the code that follows the closing curly brace and the loop is done. With the for loop, we knew that we wanted to run it 10 times. So the for loop was the best choice. But what if we don't know how many times to run the loop? Maybe we have to rely on a number a user enters, or maybe a calculation that is run ahead of time will determine how many times the loop will run. In these cases, we would use a while loop. This loop will repeat a certain number of times, or as long as a certain condition remains true. Let's look at some code that simply prints out the numbers 0 through 4, which will be the value of our variable I. This first one is the basic syntax, and we're assuming here that I is initialized to 0 to begin with. So it says while I is less than 5, print, this is the value of I, equal sign, which is all string, and then they print out the I variable. And then I is equal to I plus 1. So we see our incrementing inside of the while loop, which is important. When keyword is used with basic, and it goes back up and goes through the loop again, this time I being 2. Okay, the second one is C++. We have our integer I being assigned 0, while I is less than 5, is the condition. Then we output, this is the value of I, and then we'd put, it would initially be 0. And we increment it again with I equals I plus 1. Swift, we have a variable I being assigned 0, while I is less than or equal to 5. Do what's in the curly braces, print out this is the value of I, and then they have the I variable, and then they increment their I with I equals I plus 1. If we look at the while loops we have here, the I variable is initialized to or assigned the value of 0. So the condition following the while keyword is evaluated. Is I with the current value of 1 less than 5? The answer is true, so we'll run the code inside the loop. This is the value of I equals 0. So sorry, they're all initialized to 0 first, not 1. This is the value of I equals 0 we'll print out, and then the 1 is added to make it 1, so the second time through the loop, it will loop back up and the condition is checked again. Is 1 less than 5? Yes, that is true, so this is the value of I equals 1 we'll print out. And 1 is added to, and now it is 2. And this happens for 3 and 4 as well, but when 4 gets added to by 1 and becomes 5, the condition is evaluated again, and this time 5 is not less than 5. So it is false and the loop stops. Again, it's important you don't create an infinite loop that never ends. And incrementing I by 1 each time is very important, otherwise your number would remain the same and it would always be true and keep looping forever. Also, sometimes the logic of your condition can be faulty and remain true, and the loop will never end. So be careful with that. The last loop we'll look at is the do while loop or until loop. This is very similar to the while loop, but the condition is not evaluated at the beginning but at the end. This makes it so the loop will always run at least once, even if the condition is false. It's not used as much as the while loop, but you might need it once in a while. Maybe we want to take an integer as input from the user inside a loop. Once the user enters a positive number, it will stop. But we have to run the loop at least once in order to get the initial input from the user. Otherwise, the user might never be asked to enter an integer at all. So we have var num, and then we have do, and then inside curly braces, we are assigning num a prompt or getting a number from the user. And then we have the keyword while, and then at the bottom we have the condition num is less than 0. So we can see that loops are a great way to make your code more efficient and to repeat code again and again just for the number of times that we need it to run.